Thank you all the speakers. And now we have time for discussions. And joining me is my former colleague at UST, Jimmy Fong, and Zibing Yuan from South China, and Dr. Shah from Jinan University. Dr. Shah, would it be okay if you turn on your camera so that we can see you? Thank you so much. So if you have questions, please send in your questions through the Q&A box. Do we have questions from the audience, please? Maybe I will kick off with a general one. And it's actually for Jimmy and also Jiva, but I guess he's not here. I mean, in general, when we talk about these modeling results, and you and Jiva use the models to estimate health outcomes. So I'm just wondering, because there are also other talks talking about uncertainties in emissions, uncertainties and mechanisms. What is your estimate or feel of the uncertainty in these modeling work on ozone and PM 2.5 concentrations? I'm particularly interested in the short-term results because Jiva also talk about acute health impacts.
Okay, now in terms of the ozone predictions, we certainly have estimated the certainties compared with all the available observation stations. I would say our model accuracy is more than 20% differences versus the observation. Now, it is true that sometimes when it is an extreme high pollution episode, sometimes we may not able to produce as high peak as what we have been observed. And typically, we may be about 10 or 20% lower. But in terms of the 8-hour average, because normally the health impact, we are talking about 8-hour average value on the ozone, short-term running average. So in terms of that, we would expect the error probably would be less than 20%. So in terms of the short-term estimation on health, it still gives you a relatively good accuracy on the health risk, right?
Okay, thank you.
Because the health risk is a composition of not just ozone as well as NO2. So NO2 is quite accurate.
Okay, good, thank you.
Because that depends on the emission inventory.
Right, so we have a few questions and I'll read them out. The first question is by Jeff Bent on, so I'll just state the question. Are ocean-going vessels significant contributors to VOC emissions? I guess, I don't know, Jimmy?
It is part of the anthropogenic emission, right? Now it's definitely contributing, but in terms of when you use the word significant, what is because they are typically way out in the ocean, they are certainly contributing to the formation of ozone. Whether they will have in terms of they are actually emitting from industry on the land is very difficult to answer. But certainly, it's definitely contributing to the VOC. It certainly is a part of the in the anthropogenic emission inventory.
Dr. Shah, do you have any comment on this? Because you also work on the VOC measurements. Okay, so I guess I will move on. Jen Yu has a question, I guess, on Jibing's talk. Can you elaborate on what kind of oxidation environments?
I think this is the follow-up question of Dr. Yu's talk. Dr. Yu's question. She asked the previous question is that SOA potential is measured or calculated. Is this calculated? And we only can see the OH radical as the oxidant. What kind of oxidation environment? I think we just use the typical OH concentration data around the polar delta. We try to mimic the natural condition as much as possible. So just around several times 10 to 6 this kind of concentration for OH radical, I think.
Okay, there's a question, I guess, for everyone. I saw there is a formula showing the added risk on health, I guess GBA and GFAR, when absorbing ozone NOx. Can you briefly explain and elaborate on the factor on the formulas?
Now, I understand that beta we use is based on the local hospital admissions. We work with a group of people from Chinese U. They have the hospital admission data. So we work with them to come up with their factors. I cannot answer for GFAS one.
Okay. Let's see.
So you can say it's based on the local data, in short.
Okay, good. So there's a question from Su Gao Zhang. What are the data assimilation techniques used for NAQMS model results? Are there any specific notifications for assimilating ozone and PM 2.5? The national air quality, I guess.
I guess we need to ask GFAR for this one.
It is GFAS, is that right? Or okay, so maybe
we will pass the question to him.
Okay, so please contact GFAR Wang directly. And there's another question for Jibing from Xiaohe. I noticed the sampling of IVOC by 10x tube is after the filter. Will this bias IVOC sampling? Because the filter also absorbs IVOCs.
It's not a bias. Actually, we intentionally doing this because what we want to collect the gas phase IVOC and particle IVOC simultaneously. For those collected on the filter, we think it is in the particle phase, so it is particle phase IVOC. For those absorbed by the 10s tube, we think it is gas phase IVOC. So we have to collect it together because the temperature in our sampling system is just around 47 degrees, much lower than the temperature in the vehicle exhaust. So in the normal temperature or around 47-degree temperature, there's a lot of the gas phase IVOC that already partitioned into particle phase. So we have to collect them together.
Okay, so a question, when considering the health impacts of more than one pollutant, is it reasonable to assume linear addition of the individual health risk? So is there any studies suggesting any synergy effects?
Well, that's the assumption we are using. We know they are definitely have when two pollutants they are add together, whether bigger than 2 or smaller than 2 is difficult to say. But I guess for at the moment, there's, as far as I know, there's no other study which can tell us, you know, is whether the combination of them. It has not got enough data. So at the moment, all the estimation is just give you an order of magnitude estimation. So when it comes to mathematical modeling, so linear combination seems at this point in time is the best assumption you can make to give you that order of magnitude estimation, I would say.
So because of time, we actually have quite a few questions left, and I shall pick the remaining 3. After adding IVOCs and OVOCs to what extent SON and ozone are better predicted?
Well, this is actually not a prediction study. Probably in further investigation, we will kind of do this modeling simulation work. Actually, this is only a measurement work, and the SOA prediction is much related, much from a empirical calculation, I would say. It's not a simulation. We probably will check whether the prediction can improve in the future.
Dr. Shah, do you have any comment on this question?
Well, actually, we also didn't predict the SOA and ozone formation from these two kind of VOCs.
I would imagine there must be some importance. Otherwise, you guys would not spend all the efforts in doing this. Jimmy, you have, I think, Yao Yao, one of your former students, Yao Teng, actually included some IVOC in the modeling work together with Li Ying, right?
Yes.
Yes.
Do you want to comment on this?
You mean me or Jiping?
Yeah, Jimmy, sorry. Yeah.
Well, it definitely that by I would say there would be certain impact, but I need to refer back that paper to actually tell the, but it certainly would have improvement by including this chemistry. It's no question of that.
Okay.
That paper doesn't have the IVOC emission data, right? The IVOC part, it's just for the empirical calculation, does not have the.
We do not have the inventory. No, yeah, it is true. Yeah.
But
we have that,
the calculations, right?
Yeah, at least the calculation is included.
Okay, so it's a question from TY. Now that ozone has become the major issues of Great Bay Area and even the whole China, does it imply that continuing to reduce emissions of NOx and SO2 does not help?
Well, continue improve in NOx would definitely help because NOx is one of the precursor of ozone. So if we are continue cutting in terms of the health benefits, although you continue cutting of NO2 and then will lead to a slight increase in the ozone, but the overall health impact is positive by cutting aggressively on NO2. So I would expect, you know, of course, we should cutting VOC as well, but at least we should not lessen our effort of continue cutting NO2 in long term of, you know, to reduce ozone in a long-term basis.
Okay, so there's the last question for this session from Grace Cruiser, and this to you, Jimmy. Your talk suggested that Hong Kong is in VOC limited regime, but as there are much effort to reduce NOx in the PRD, would Hong Kong more likely to become NOx limited?
I think it will be quite a while when everybody else will continue cutting NOx quite aggressively in order to change into this particular regime. But at least Hong Kong is not just aggressively cutting NO2. We are certainly working with the Hong Kong government as well as the PRD regional government, establish the VOC emission inventory, aggressively doing various field measurement campaigns to understand the various VOC forming potential of ozone. So we will see in the next 2 or 3 years, I would expect the PRD region will be aggressively controlling VOC as well. So hopefully with this both pollutant cutting VOC and NO2, the downward chain of ozone will be happening in the very near future. That's what we hope. Yeah.
Okay, with that note, we conclude this session, and thank you all the speakers and also all the panelists and all the audience joining this session. Thank you. Bye-bye.
Okay, thank you.
Take care, guys.
Okay, bye.